So I talk about all the good stuff that we do. The first thing we kind of want to mention, like if you want to come to the workshop, we're running a workshop later today. You can already download the dependencies now, and it would be cool if you want to join, if you start downloading the dependencies beforehand, so you kind of have everything before we get up and running, because we only have 2 hours for the workshop. I will tweet it out afterwards again, but you can just go to that IP address. I hope I still have that one on my laptop. And we just have all the dependencies that you will need for the workshop there. So you can go to that address now and start downloading all the stuff that you need. We have different sections for different operating systems. You will need VirtualBox. So if you have not installed VirtualBox, install VirtualBox. I have a link there to the different operating systems. And we have a base image, and you just need to download the base image. You don't need to load it or import it already. You just need to have it locally on your disk. So if you want to come to the workshop, please get the dependencies. Otherwise, we will spend a lot of time until everybody has downloaded everything. Was anybody able to reach that site? Did anybody try it? It's working? Good. So once you're there, you can start downloading, and please do that, and so that we're faster afterwards. And the talk is kind of a bit more on the theory side now, so now we'll just dive into like what is going on and how do we get here, and the workshop part is then like how can you actually use that stuff, but we'll get to that later. So the idea is kind of to log all the things, like combine everything and see how we can get everything together. So just to get an idea, who's using more than 5 servers or containers? Anybody? A few? Okay. And kind of the next question is then, how do you log? Who's using SSH plus tail? Anybody admitting? No. Okay, good. So just assume in case anybody would use SSH plus tail, it works fine for 1 server, for 2 servers, but at some point it's probably getting a bit cumbersome. You don't really know what is going on. You cannot keep the overview. You just have lots of open windows and tabs, and you don't really know where to find stuff. You somehow want to centralize that. And we have something called it the Elk stack, Elasticsearch log/Kibana for logging. Who knows the Elk stack? Who has heard of that? That is very few, actually. Interesting. So we had the Elk, and my colleague David, he even has the toy Elk with him. But yeah, the Elk was working very well. Elasticsearch to store the data, Logstash to collect all the information, and Kibana to visualize it. The main downside was that if you're not a Java programmer, which you're not, but at other conferences, people complain a lot about having Logstash, which always needs the JVM to collect the logs. So you have Logstash, which can get the logs, parse them, and then forward them and store them in Elasticsearch. But if you were not a Java programmer or you didn't need Java on 1 server, people were not keen to add the JVM just for logging. So we added another project called Beats, which is written in Go. You have native binaries and no dependencies, and it's basically a forwarder or agent or shipper or whatever you want to call it that can collect various pieces of information and then can just send them away. And then we didn't really kill the Elk. We just tried to rebrand because there is no B in Elk. And it's kind of, yeah, where are we going from here? And then we tried with that one. So you can see that we call it the Belk or the Elk B. And you can see we have the B and the Elkhorn, so it's kind of the combination. And that was actually very nice. The main downside then kind of was like, Elasticsearch is always about scaling. And then marketing decided that this mascot wouldn't really scale, because what happens if we want to add another open source product to that? Then we would need to change all the branding again. So it wouldn't really scale. And then they were like, yeah, it's nice, but it's not really what we want. And then they kind of went for the boring option and just called it the Elastic Stack. So it's also a bit to strengthen the brand name. And what used to be the Elk Stack, we now try to push as the Elastic Stack. And it's just all open source. You can just use it today pretty much. So what you get is you have the beats, which are collecting your information and are forwarding, and they can either forward directly to Elasticsearch or forward to Logstash. Logstash can then do this parsing and enrichment. So parsing would be you have a log line, and you want to extract meaningful information like the path from where the log was, the error level, if you have HTTP calls like the response code or the URL, and you want to parse out that information that you can easily visualize that afterwards. Or you could do more complex enrichments, like if you have IP addresses, you probably want to know the geolocations of those IP addresses. So you would find out, or you could then query like, who visited my site from Belarus in the last week? And if you do this lookup, you can very easily do that. So if with the geo IP lookup, you just have the IP address and get like, okay, this was this city and this country probably. And that will also store the information in Elasticsearch afterwards. And Kibana sitting on top is then visualizing all this stuff. And we also kind of combined all the versioning schemes since all the projects started at different points in time and then joined, we always say they joined the family. So they joined the Elastic family, but all of them had different version numbers. And people were a bit confused, like what is working together? So we had Elasticsearch 2.4 working with Kibana 4.6 and Beats 1.2, and like all the different version numbers were not really well aligned. And even for us, it got confusing at some point. So by now, all the versions are exactly the same. So 2 days ago, we released 5.4.1, and then we will release 5.5 at some point and 6.0 at some later point, but all the versions have one version number and are released in the same process and on the same day. And let's jump into beats now. So the first beat we have is file beat, which is pretty much like a log/forwarder. You have your log files somewhere, and you want to collect them and see what is actually going on and centralize that. I always describe it like it's like tail F, but over the network and kind of on steroids, because it's more powerful than what you get with tail F. So the parsing and enrichment is still logstash or the new ingest node, but we won't go into those details now. We just care about the forwarding part. The nice attributes of FileBit are it supports at least once, so you will not lose your log messages, but they will be submitted until they have been collected by the next step. You have back pressure, so if the receiving part is overloaded, FileBit will just slow down and not overload the receiving system. And you have graceful downtime that FileBit will actually recognize like the receiver is down. I will not send you anything now, but I know everything I have sent you so far, and I will send you everything afterwards then. So what that looks like is you have the beats, you have your dozens or hundreds or thousands of servers somewhere, and you have the beats running on all of them, and they collect your log files. And then they will just collect to one of the, I'm using Logstash here, you have some Logstash instances, and they will just randomly pick one and will send the requests in a round-robin fashion to all the Logstash instances. So if one of them dies here, FileBit would pick another one and just keep sending that information. So that, as long as you have multiple here, that should be very resilient, and it will forward the information, and you can receive it and process it further. And what it actually looks like for one beat is that one beat is reading a log file. So that thing up here, the stream of log lines, that is one log file you're reading, and you're adding your errors or ones or whatever continuously to that file. And you want to collect and forward that. So what FileBit then does is it takes a chunk of that file, not just one message, that would be too inefficient. It takes a bunch of messages and sends them out. So you can see the yellow part, the red part, that has been read, that has been sent as a batch to Logstash, and at some point, hopefully, Logstash acknowledges that one back. And as soon as it has been acknowledged, that would be grayed out then and put under the acknowledgement. And we have this pointer in the so-called registry file, and then that pointer would be forwarded to the end of the yellow area, and then we could send the next chunk. And that pointer is actually how you can do stuff like graceful downtime, because it will just recognize, okay, I have sent everything up until here. The other side is not available, okay, I will just wait, I have this pointer to that file here, and I will send everything afterwards. And since this is using inodes on Linux, even if you rotate the file, so if you have a rotation pattern and you rotate your file, I don't know, at midnight or something like that, the inode will still be the same. So even if you have not sent everything and rotate the file, the registry file will still know this is the same file and you have sent everything up until here, and I just need to send that last part. Or it knows, okay, you have sent everything, you rotate, and you don't need to resend everything from the rotated file. So that plays nicely along with any other Unix tool you have to rotate. I think it works on Windows as well, though I haven't tried it and I haven't touched Windows in a long time. Another few nice attributes is if you have multiline statements, what would be a multiline statement in Java, for example, in a log file? Yes, the dreaded stack trace. That can be a pain because FileBeat normally just assumes every line is a statement. But in a stack trace, that is not really the case. Like there it's multi-lines, and you want to keep them together. So what you can do is you can tell FileBeat to have a pattern, and everything that starts with a specific pattern is one message, and everything that is not that pattern is another message. So you could say every log entry I have starts with a square bracket, and everything that doesn't is just the continuing message of the previous square bracket. So you could just say like square bracket, and everything until the next square bracket is one message, and you always keep that together so you don't break up your stack traces. Because otherwise it's very hard to keep track of what is going on in your stack traces. You can do filtering on your server already. So you could log in debug, but you can say I only want to centralize everything that is error or one, because debug is just too much information. I don't need to centralize that. So you can filter that down in FileBeat already. And if you have JSON, we generally recommend to log in JSON just to have it structured and you don't need to parse it afterwards again. You can just send a JSON, and since Elasticsearch is storing JSON, you don't need to do any parsing. You can simply insert that JSON file directly into Elasticsearch and you're basically done. And we recently added FileBeat modules. Those are very nice. They just previously it was a bit hard because you always had to tell like FileBeat, this is the location of the log file, and then you had to tell logstash, this is the pattern, how to actually parse that message. And FileBeat modules kind of go one step further. They just know like on your operating system you have enabled the Nginx pattern or module. And then it knows on your operating system, Nginx has its logs in var log Nginx, and the pattern looks like this. And it will do all of that for you in the background. You don't need to do any further steps. You just need to activate those modules, and currently we only have these 4 applications. We will add more in the future. But any of these applications, you just need to enable the module, and everything will be picked up automatically and forwarded correctly for you. So, since we talk about Docker, by the way, who is using Docker in general already? That is just a few, okay. Who is using Docker in production? Even fewer. It's kind of the common theme. So to use Docker in development, it's nice. You just spin up something, it works, you throw it away if it doesn't work. To go to production, you need a bit more tooling around it, because you really want to, for example, do stuff like logging. And with Docker, you have lots of options. So actually, we have basically 101 options. If you go to the driver overview of what you can do, these are all the ones that are supported in general. Which ones are relevant for us? We'll just quickly go through all 101. So the first one is the default, the JSON log file. So it will write out the JSON log file in a specific folder in your file system, and you can just collect that. It contains all the metadata, it's simple, it's the default. Main downside is it is maybe a bit slow to log out in JSON with that driver, like some people have complained about that. And the other one is, the default is that that file will grow unlimitedly. You can configure patterns, rotation patterns, but you will need to configure them explicitly. The next option is syslog. So you can just run your own syslog server, forward information to your syslog server, and from that syslog server you can then collect it with FileBeat and forward it. The main downside is, you need to run your own syslog server, and it's a bit harder since you have to like send it to syslog and you serialize and deserialize it there again. You might screw up some patterns, and then especially with multiline statements, parsing can get a bit more complicated. Then we have journald. Thanks to systemd, journald is not going away and it's just growing and growing. It's nice because it supports Docker logs, has metadata and everything. The downside for us is that we don't support journald right now. So luckily somebody from the community stepped up and created something called journalbeat, so that can collect information from journald. We will probably take over that module. I met the author a few months ago, and he was like keen to hand it over to us, and we provide it officially, and have it supported and everything. It will take some more time. I hope we get journal D at some point. And then we have the GELF appender, the Graylog extended log format, which is nice. The main downside is, or for some people it's an upside, for some it's a downside, it's UDP. So it's just fire and forget. You don't have acknowledgements. You don't really see that the other side is down. You cannot do slowdown or do back pressure of the sender. It's just like, you just keep sending your messages and the receiver needs to keep up, which can also be an advantage because maybe you don't care if you lose one log message. And it's also a bit more lightweight than TCP. So using TCP or UDP is always a point for discussion. We generally lean towards using TCP because you don't want to lose any important log messages. But some people feel more comfortable using the more lightweight UDP. And then you can mount out the file system. If you have a well-behaved application that just logs to some path, you can do that. If that rotates that thing, it's nice. The main thing is, since you mount out a file system, you lose the Docker information. So you don't really know to which Docker container that log file belongs anymore. And those were already the 101 options. Luckily, they were only binary. Otherwise, it would have taken much longer. So today, pretty much, we would recommend to have JSON, syslog, and volume. In the future, as soon as we have kind of journal D support, probably journal D is the nicer thing to have. Next up, metric beat. In the beginning, we had something called top beat, and it was doing the same thing as the Unix top command, even though it was always supported on Windows as well. And we still do that. So we have the system metrics. We can collect all of these metrics, so we know what is going on your system, like which processes are running, etc. But we also added something new called the services or applications. So if you have any of these services running, we can extract meta information from them and see what they are doing. So if you have, I don't know, a MySQL database or a Postgres database running, we can just, they have interfaces to provide statistics, and we can query those statistics and store that. So we get out how your applications are doing, like how many requests are you serving, how many errors are you doing, how many page faults do you have, stuff like that. We can just get meta information out of that. If you're using a Java application, we have an integration into JMX through Jolokia. So you can just ping a Jolokia endpoint and extract that information from your Java application. So if anybody is doing JMX, anybody doing JMX? Anybody Jolokia? That is very few, okay. So Jolokia is kind of the saner JMX protocol, or the nicer thing to use. So to query your application, you can use Jolokia and JMX. In the context of Docker, the first thing you can do is you can just read the information from proc, which is part of the system, which has the big advantage is you don't need access to the Docker API. Because once you have access to the Docker API, you can do everything you can do on the Docker API. And maybe your logging system should not be able to stop your containers or to change your containers or do anything like that. So some people strongly prefer that their logging system can only read stuff but not access the API and change stuff. So for security reasons, it might make sense to prefer that approach. And other things are, we support all the container technologies since proc is just very generic. Anybody using anything else than Docker? Any other runtimes? Yeah, that's pretty much the common picture. Everybody just cares about Docker, which is fine. That works as well. We just use the cgroup information. We enrich our stuff. Main downside is we don't support anything that is Docker specific. So Docker labels and names, we cannot really support them because we're just using the generic proc information. And then people are always like, yeah, but we only care about Docker. Everybody just wants to do Docker. Even though I think that is the real Docker logo. Docker will eat everything like you and all other Docker container technologies. Docker will really, yeah, eat. You're the little fish. You're a Nemo. Like, that is your position. So somebody from the communities thought like it would be really nice if we had that API, and they just implemented it since it's very easy with the beats. And they called that Docker beat, and they were nice enough to write the version 1.0 at some point, and then wrote a blog post on our blog about that. And then, yeah, we had to kind of take it down. because Docker Inc., the company, reached out and said like, well, Docker as the first name part is trademarked. And you have lots and lots and lots of projects on GitHub which do that. And Docker could kind of have or take down all of them. But it's like, as long as you're not visible, they don't really care, and you can do whatever you want. But as soon as they feel like you're becoming too visible, they will enforce their intellectual property and tell you to get rid of that. So then we were thinking like, what could we do? Like, how are we naming this thing? And the thing they came up with was that. So since they only had the trademark for Docker and not Doc, it was named Docbeat. We also even thought about just removing the E and just have it Docker beat, but we stuck to Docbeat now. So the project is on Docbeat, but the person who wrote that was kind enough to actually contribute that to MetricBeat as well. So if you're using MetricBeat, you have that as a module included now as well, so you can actually use the Docker API too. I will show you afterwards how that looks like. If you want to use the system permissions and you run your Docker container as a sidecar, which is probably what you want, you will need to give permissions to read the host system. So to do that, you just mount some folders, like these are the locations like proc, sysfs, cgroup, and the base system. You mount that into the Docker container as read-only, and then you can collect all the information you need to monitor the host system from a Docker container. If you want to allow one Docker container to use the statistics API of an application in another Docker container, you will need to link them together correctly. So here, for example, I have my MetricBeat, which monitors some MySQL container, and that container needs to know, like, how do I access that MySQL database to get the statistics out? And that is what that command would do. So we just link them together, provide the credentials, and then you can actually log in to get the statistics that you need. And as I said, the general idea is to run it as a sidecar. So some people ask, like, should I put the beat into my container? Probably not. Should I put it on my host system? You also don't have to do that. You can just run it as a sidecar in its own container. So the beat is just running in that Docker container and can monitor both the host and other containers. And that's kind of our recommended setup. And then people always ask, like, you started off as full text search. Is that any good for metrics? And people always ask, like, do you have any benchmarks to compare yourself to others? And I'm always putting out that one, which I think is the best description of all the systems doing benchmarks. There was, like, some time ago, there was this situation where MongoDB, Cassandra, and Couchbase, each one of them benchmarked against the other two, and each one of them found some scenario where they were at least twice as fast as the other two. And each one of them managed to find that situation. So this is really pretty much that scenario where you benchmark who is smarter, the squid or the house cat, and then you basically drown the house cat, and then your conclusion is that the squid is more intelligent. That is what pretty much all of those benchmarks try to achieve. So we don't really do benchmark with other systems, we just benchmark our own. But yeah, we can store lots of metrics by now and store them very efficiently. We also added more data types. So previously we only had float, and float was nice, but float is just a bit too much precision for your average problem. So if you just monitor your CPU, you probably don't need the full precision of float. But there are other data types we can use. So we have half float, which basically is half the precision for half the space. And there are also scaled floats. Like, scaled floats are very interesting. You basically store an integer number, but have a scaling factor. And you basically divide by that scaling factor to get the original value. So if you store 101 and you have a scaling factor of 100, the original number would be 1,01. So you have the scaling factor. But it doesn't have to be 100, it can be any number basically. You just store an integer number, divide it by the scaling factor, and that is how you get back to the original value. And that's what we store. And as you can see, it's saving some more disk space so you can get more efficiency out if you have lots of metrics. If you just monitor a handful of servers, you probably don't care that much. But if you have lots of metrics on hundreds or thousands of servers, it can add up over time. Next up, we're using PacketBeat. Anybody using Wireshark? Wireshark, just very few, okay. Wireshark is very nice as long as you're on a single server. But if you have any distributed system, Wireshark gets a bit more complicated because then you need to trace on all these different servers and then combine these traces to get the overall picture what is going on. That's why some people say like having any distributed system is more like a murder mystery, because like you get all these bits and pieces of information from different systems and then you're the detective and you need to put it together. And PacketBeat is kind of trying to avoid it. So PacketBeat is using the same base library, libpcap. It will collect your network data, parse the network headers, and forward that. So we support quite a few protocols. If you're using any of the databases, HTTP, we can parse the network headers of these protocols and then know, okay, this was the request, this was the response. The whole thing took 100 milliseconds. Your protocol was HTTP, so the response code was, let's assume, a 200, and the URL you hit was foobar. And we can extract all of these informations just from the network headers and store that. So that is very easy to debug afterwards. And if we don't support the protocol yet, or it's encrypted, since, yeah, there's no magic, we cannot really look into the encryption, then we have something called flows. Flows are pretty much like TCP IP information. So we know who is communicating with who, how much traffic, how many packets, but since it's encrypted, we cannot see into the packets, or we just don't support the protocol. So we still know who is talking to who, and we can tell you like, this IP there is generating all the traffic. And again, you can run it as a sidecar. With the right setting, you can monitor both the host system and then the other containers, and that is kind of the way you should probably set this up. Then we have added something called Heartbeat. So anybody using Pingdom or any other pinging service to check if their services are up and running? Yeah, okay. We were using that a lot as well, and since we have our own cloud offering, the cloud team was using that. And at some point they thought, well, we have this stack and we use our stack for everything else. Why are we not pinging stuff internally? And that's why the cloud team started with something called Heartbeat, so that can ping your service, and it will actually say, the service you're pinging is up or down, so it supports the protocols TCP, HTTP, and HTTPS, but it will also record the response times. So you will know that suddenly your service is responding much slower than it used to, or your service is giving you an HTTPS error or something like that. So we can ping services and store that information, and you will see like what is up, what is down, what the response time of something is. Anybody using Windows? I'm sorry for you. No, I'm joking. I haven't touched Windows in a long time, I must admit. I have still old memories, like there is the Windows event log. So all the stuff that is going on in Windows, you have this, for me now, weird application where you can see what is going on, but you don't have to use that anymore. You can also extract those Windows events to Elasticsearch with something called WinLogBeat, so we can get those out as well. And then the question is, okay, where are the Docker containers? How can I get this up and running? Yes, we have everything up on GitHub, and we have named everything correctly in the beginning, so we didn't change the naming schema afterwards. We had Docker at the end always, to avoid the trademark dispute. So you can get all the containers up from there. And this is the minimal example to have just Elasticsearch and Kibana, the front end, so we don't have any data collection like Beat or Logstash running here. This is the minimal setup to just have Elasticsearch and Kibana up and running. Do you see anything slightly unusual or maybe surprising? Am I using Docker Hub? Yes, no, maybe. No, I'm not using Docker Hub. We're using our own registry. We're using docker.elastic.co/whatever, Elasticsearch. So if you're just using the image Elasticsearch, like if you left out the docker.elastic blah blah blah, just Elasticsearch with whatever version, then you would get data from Docker Hub. And that is what still quite a lot of people do. The problem is, those images on Docker Hub were even marked as official, but that was kind of a bit of a misunderstanding, because the Elasticsearch package on Docker Hub was only always Docker Inc. official, but not Elastic official. So we never were involved in any of these packets. And we then decided we want to do our own packets for two reasons. A, we're using Docker images quite a lot internally as well. And we need to spin it up new clusters, so we have SLA guarantees. So we cannot really guarantee that if we don't host it ourselves. And we were not that happy with Docker Hub's availability and speed. So that was one driver why we started our own Docker registry. And the other one is we have a lot of download statistics, and we really know like how many people downloaded our products in which version from Belarus yesterday. Like we could look that up afterwards. Like we really track that. But from Docker Hub, you don't get any statistics. You don't see what is going on with your products anymore. That is why we want to have this mechanism to see who is actually using our images, and the reason why we have that. That the official Docker Hub images are deprecated by now, so there will be no more updates. So you should switch over to our official packages at some point. Anybody using Elasticsearch in Docker already? Are you using the official images, like ours, or the Docker Hub ones? The Docker Hub. Did you know we have our own registry? Yeah, that is kind of a common theme. Like, I'm trying to get the word out. We have our own registry. We try to help people to get there. The other thing that is maybe not that obvious is that we don't have latest anymore. Who is using Docker and is using latest? Anybody? Okay. Why? I mean, it's okay for testing, but it's probably not what you want for production. And we started off providing latest in the beginning as well, but then we quickly realized that is not a good idea. Because what will people do? Like you spin up a cluster today and say, I want 3 nodes with latest. And then that is running, and then the data is growing. And in half a year or so, you want to add 2 more nodes. And then you add 2 more nodes again with latest. And then you will probably screw up your cluster. And we don't really want that. And otherwise people will come to us complaining and screaming and like, you broke our cluster or whatever. And that's why we don't do latest. It's a bit more work for you, but you will always need to provide that version, just so you don't break your cluster later on. Another common question or thing is like, what is the base image? Who's using Alpine as a base image? Anybody? Alpine? No? What is your base image? Debian Ubuntu, anybody? Anything Red Hat based? The rest doesn't know, okay. So we started off with Alpine because it's very small and everybody's saying, yeah, that is kind of the future. And we kind of failed because it's not using the base library glibc anymore, but the Musiel library, and lots of stuff is different. And it was kind of a painful process for us. So we ran into some very weird bugs. And we could never get Kibana up and running on Alpine because at least previously Node.js, on what Kibana is based, was not officially supported on Alpine. And we were always like fighting Alpine. And then we kind of decided, well, most of our customers are in the US and most people in the US are Red Hat based. So now we have switched everything to CentOS base images. They are a bit larger, but you normally don't deploy your Elasticsearch cluster 20 times a day. So if it's a little larger, it doesn't make that much of a difference. So for demos or stuff that we will do, that is the base box, the top one, the Vagrant image, that is what we will use in the workshop, so I don't need to dive too deep into that. I also have everything based on pure Docker, which you can get there. But I'll just show you quickly what we have done with Docker. So if you have never seen Kibana, this is Kibana, and this is the new version, version 5. I always describe it like version 3 was the black one, version 4 was the white one, and version 5 is the colorful one. You probably feel pretty much at home. Like, you have probably seen Discover, Visualize, and Dashboard if you have ever used Kibana before, but it was like in the top bar here. We've just switched that to the left-hand side, but otherwise 4 and 5 are very similar. And you should feel pretty much right at home. So here you can see over the last 15 minutes I have collected a lot of metrics, since this is the view of metric beat. I have all my 4 beats, not the WinLog beat, since yeah, I'm not doing Windows. But the 4 other beats are running and are just collecting information here. So you can see over the last 15 minutes, metric beat collected 15,000 events. one of them is Docker. So we could just filter down to that. So there is somewhere, you see we have lots of fields. We have a metric set module, and you can see here we have Docker. And if I'm just interested in those, I don't want to see system now, I'm monitoring Mongo, Nginx, and Redis as well, but I don't want to see those. I want just to filter down on Docker. You can just click on that little plus sign here, and then you can see I have this filter up here, and it's currently reloading, and suddenly I only have my 500 Docker events. And then you can just look into one Docker event. So you can see I'm reading var run docker sock, so this is where I get the information from. This is just an info message, and you can see that I have one container running here. No containers are stopped, no containers are paused, one container in total. So we're just extracting the statistics from that socket. And if you switch to another one, you can see, okay, here I have a container that is called my Redis, and it's up for 9 hours, and we're just extracting all of that information and store that here. And then you can also visualize that. Since I'm lazy, I didn't build it myself, I just use what we have pre-built. So if you go to dashboards, and I have loaded our dashboards, there are various things, and we will look into more in the workshop. But let's just switch to the Docker one right now. So if you switch to the Docker one, you can see what are the containers you're running. I just have one my Redis. You can see, yes, it's up and running, 0 paused, 0 stopped. That was also the log message I've just shown you. So that was that document here. Then you can see, like, okay, on one host, I have that running. I have 2 layers in my image. Like, I have the Redis image, and it's wrapped in my Redis. And then you can just see, like, CPU usage, memory usage, and I/O, and network traffic of that image. And if you had multiple images, you could see it for all of them. But you can see this is how your one image is doing, and you can see it's the memory usage is pretty much like a garbage collection. So it's doing something, collecting something, then it's throwing out stuff, and yeah, that is working fine. And you can totally switch the time frame. So I think that has been running for an hour or something like that, and you can see, okay, this is how Docker is doing. You see, total CPU time is pretty minimal. Yeah, it's using up to 80 megabytes of memory pretty much. And the network traffic is also pretty minimal, so that container is behaving well. But if you have lots of containers and you don't really know what each one of them is doing, that is definitely a nice way to see what each one of them is up to. And you can just collect the information and see what is going on. So this is just from the Docker socket. We collect the information. So the metric beat is monitoring the Docker socket, storing that information in Elasticsearch. We have seen under Discover here, that was the Discover view. In Discover, we've seen one document, and in the dashboard, we actually see what those numbers look like. So that is just to get an overview of what that is doing. And just to give you a very quick idea, so I get rid of that, I switch over to FileBeat. I'm collecting various things from the file system. And here we can just say, I'm only interested in my Docker logs. I'll filter down to that one, and to little surprise, you will see, okay, this is where that file is located. So I'm just using the default JSON log to log my Docker from my Docker container, and you can see, okay, typical Redis message. So we have just collected that, and in the workshop again, we can jump into more of those details then. Okay, to conclude, Lego. I always compare the stack pretty much to Lego. Like, you have all the building blocks, but you still need some assembly to put it together. Like, you have the pieces, and then you assemble it a bit, and then you can make everything up and running. It's not really like a solution out of the box. You just start it and it does everything for you, but there is some small configuration needed that you have to do. The other thing, we just focused on the open source part. Like, this is the dashed line. How is my salary paid and David's salary? I'm sure his is much bigger. We have a cloud offering, so if you don't want to host it yourself, we provide that. And we have some commercial extensions, so if you have anything about security or graph, or we have machine learning added now as well. So those together with support are how the company actually makes money. But those products here, we don't have a commercial version of those. Those are just in the open source version, so you can use that. It's Apache 2 license. There's like no tricks attached. If you now want to say like, all of this is very useful, but I only care about the Java application, I also have a talk about how to monitor your Java application. So that is pretty much a Spring Boot application, and I'm just monitoring the Spring Boot application with the actuator and the actual log from the Java application, and I'm using Zipkin for distributed tracing and stuff like that. So if you want to try that out, I have another repository where you can just try out how to monitor a Java application. Don't forget the workshop, like 3 to 5 in the 3rd room. I haven't really figured out where that one is, but I guess everybody will find it. And with that, more stickers. We also have flyers. And I think we have time for 1 or 2 quick questions. Or no time? 2 minutes, okay, perfect. 2 minutes for questions. Any questions? Yes. Hi.
Hello, thanks for presentation. And one question, how do you manage a big amount of historical data? And second question, do you have Kibana and public Kibana configurations for dashboard?
Sorry,
I mean,
public?
do you present and publish your configurations for Kibana dashboards?
Oh yeah, so the Kibana dashboards are actually, those are just the pre-built dashboards. I'm just, like, they're provided by us, and I've just imported them. All the dashboards you've seen here, I've just imported them. So there is, like, yeah, that is all open and you can just use it. We'll actually play along with those in the workshop. The other thing is, so there are 2 things. Normally, if you store data, we recommend that you have like a time-based approach. So you have like one index or collection of data per day or week or whatever. And you can easily manage that and just throw data away after some time. So if you probably only care for your logs for 30 days or 90 days or something like that. And if it's longer, you can just throw away all of them. If you want to do something like roll-ups, like you want to aggregate the data into bigger chunks, like today you care about 1 minute intervals, but in a week you only want to have 1 hour intervals because it's easy to compute and you don't need that much disk space. We don't have it yet. It will come out soon, though I'm not sure if that will be free or under what license that will be. It will be called roll-up. So you can roll up the data and basically aggregate it together into multiple. So you can just say like, take 1 minute intervals, take 60 of them, put them in together into 1 hour, and I just want to store the average, the maximum, and the minimum in that time frame to store that. And wait, I'm normally always taking a picture with you, so I can prove to my colleagues that I've been working. I mean, David knows that I've been working today, so it's better. But smile, everybody. Any more questions? Any more time? No time. Okay. I'm around for the rest of the day. If you have any questions, just find us. And if you want to get your hands dirty, come to the workshop afterwards. Thank you.